mistake.
That's okay.
So yeah, too much because I know time marches on, but I am looking forward to hearing some of the specific challenges faced by Gulf states and the UAE in the race to net zero. So that I am very much looking forward to this, and I'm sure the rest of you are as well. We're going to be running this more or less as an ordinary conference would be run. You've received an agenda, there'll be papers issued afterwards. Obviously, there's the added convenience that tea and biscuits are available at any time. So if we exceed the meeting limit, it will be available as a stream to anyone join in. So if the call looks slightly different to what you usually expect, that's why. And that's it. I will be handing over to Farah Naz, who's CIBSE UAE chair, and Azra Hussain will also be contributing from CIBSE EN. So a couple of conference rules. First of all, cameras off. I really, really want to stress that. You will be muted and you won't be able to unmute, but the cameras is something that we can't control. So please turn them off, just out of respect for the speakers and for the rest of the participants. Feel free to contribute your thoughts in the chat. The panel discussion will try to cover some issues, but it's not a Q&A session. I must stress that. And stay for the duration of the event to claim your attendance certificate. Any help, please email Jade, who's also on the call, and the email is there if you need any technical assistance. So that is all from me.
Thank you, Julian. I just want to reach out and say a warm welcome to each and every one of you for joining us today. This is our first Net Zero conference organized by CIBSE UAE. So a big thanks goes to our organizing committee and our YEN committee, and especially all our speakers who have given us their valuable time. The whole world has declared climate emergency in 2018, 2019, and we have all gone through a year of pandemic where in different ways and forms we have been working from home or going to the office. And there's a big conversation happening globally about the Great Reset. And on the back of that, we all know that 40% of the global greenhouse gas emission comes from the built environment. So today and tomorrow, we have experts from GCC and globally who are going to share their experience, their challenges, their lessons learned. And we really hope that the people who are attending, you engage with our speakers, put your questions on the chat line, and if we can't cover it in the conference, we will be responding on our LinkedIn and social media. But the idea of this conference and the intention for today and tomorrow is to really bring in the knowledge that we all have within the GCC and globally, and create this open dialogue and conversation. With that, I would like to introduce our moderator, Azra Hussain, who would be moderating a panel discussion today. Azra, can you turn your camera on so everybody gets to see you? And a big thank you goes to Julianne, who is our MC for today. And with that, I will leave it to Julianne to take the next steps. Thank you for joining us, and a very good afternoon, morning, and evening to every one of you who are joining globally to this conference. Thank you for your support and your time. Julian, over to you.
Hi, thanks, Farah. So what I'll do next is, I really want to stress that cameras please go off. I don't really want to name and shame people whose cameras remain on. So that's just one thing to bear in mind, please. So I will introduce Maj Fayad, who's technical manager at the Emirates Green Building Council. This is our keynote presentation with an introduction to UAE policy framework on net zero, Emirates Green Building Council, and its role in advocating net zero in the region. So yeah, without further ado, Maj, if you can start sharing.
Thank you, Julian. Can you see my screen?
Yeah, great.
Okay. Thank you again. Good afternoon, ladies and gentlemen. Emirates Green Building Council is very pleased to be part of the first CIBSE UAE Net Zero Conference and to support it as a knowledge partner. I would like to welcome you all to this webinar and echo Farah's words. I hope you all are doing well and staying safe during these critical times. Unfortunately, I've been experiencing some technical issues with video, so allow me to join you only by voice. My presentation today will focus on the net zero movement in the UAE, the definition of net zero energy buildings, the challenges, opportunities to the spread of net zero buildings in this part of the world, the UAE government initiatives, our zero energy, zero carbon building certifications, and at last, I will share two fantastic case studies that are registered under the zero energy and the zero carbon building certifications. I would like to kick off by sharing a brief about our Net Zero Center of Excellence. In 2017, Emirates Green Building Council joined the World Green Building Council Advancing Net Zero program and published a first of its kind paper on nearly defining zero energy buildings. In 2019, we've established our Net Zero Center of Excellence to advance the net zero movement in the country. The center offers a platform for different stakeholders, including government, public sector, and academia, to share knowledge and learn more about net zero energy and carbon buildings. We work closely with government, and we aim to drive policies and future building regulations towards decarbonization. The Net Zero Center of Excellence also offers tools and resources to advance the net zero movement in the UAE. I will share some of these resources towards the end of my presentation. At first, why we are focusing on net zero buildings? As Farah mentioned, as per the IPCC report, the famous IPCC report, we are not on track to limit the global temperature rise to 1.5 degrees Celsius and to achieve our climate targets. Another IPCC report highlights that the Arab region is one of the most vulnerable regions in the world to the consequences of climate change. The average mean temperature change in the Arab region is expected to increase by 1.9 to 2.6 by the mid of the century. UAE, as part of this region, is also impacted by climate change. Climate change will result in higher temperatures across all Emirates. The climate projections conducted by the Abu Dhabi Global Environmental Initiative show a 2 to 3 degree increase of average temperatures in the summers of months of 2060-2079. Humidity levels are expected to increase by 10%. Also, precipitation were an increase of 50 to 100% from the current amounts for Dubai, Sharjah, and the Northern Emirates. Furthermore, the probability of extreme weather events is projected to increase in both frequency and magnitude. So obviously, we need to take rapid action to avoid these harmful environmental impacts of climate change. As Farah mentioned, buildings and the construction sector play a vital role in mitigating climate change. Globally, buildings and the construction contribute to 39% of the energy-related CO2 emissions, 28% coming from operations of buildings, and 11% from embodied carbon, or emissions associated with building materials and construction processes. Unfortunately, there are no figures and statistics for the carbon emissions from UAE buildings. However, as you know, our buildings consume large amounts of energy due to the large cooling demand. Buildings are estimated to contribute to 70% of the electricity used in the UAE. Also, up to 70% of this electricity is used for air conditioning. And according to the Federal Electricity and Water Authority, an average UAE resident consumes 25 kilowatt-hour of electricity per day in comparison to a global average of 15 kilowatt-hours. Furthermore, and according to benchmarking studies done by Emirates Green Building Council, there's a huge difference between the best building performers and worst performers in terms of energy and water consumption. So having said that, we believe that buildings provide many opportunities to support reducing the carbon footprint of the UAE. The UAE government has put concerted focus in this direction, resulting in a significant shift towards the adoption of sustainability principles during the last decade. Inspired by several federal strategies and local initiatives, several Emirates have led the way by developing their own green building regulations. Istidama operating system was launched in 2010 and is mandated in the Emirate of Abu Dhabi. Dubai municipality have also introduced its green building regulations and specifications in 2011. And it's mandated for all buildings, new buildings in Dubai starting 2014. In September 2016, Dubai municipality has also introduced a new rating system, a SAFAT rating system, to strengthen the sustainable built environment policy of the Emirates. Most recently, in 2019, the Emirate of Ras Al Khaimah launched its own regulations, Barjeel Green Building Regulations, and Barjeel is mandated for all new constructions as of January 2020. Turkey Sports, Customs and Free Zones have also implemented green building regulations along two paths since 2008. First, by adopting the LEED rating system, and second, using an in-house green building certification path. Some figures that showcase the successful implementation of these initiatives are presented here in this table. As you can see, there are more than 19,000 completed buildings that, in Dubai that follow the Dubai Green Building Regulations and Specifications, and more than around 2,500 buildings in Abu Dhabi comply with the design rating of Istidama. All over, nearly 64 million meters squared built-up area were constructed using local green building regulations. Out of these, 35.3 million meters squared of the total built-up area of these projects follow the Istidama operating system, whereas 26.9 million meters squared of completed projects follow the Dubai Green Building Regulations and Specifications. LEED has also gained a great momentum in the UAE with a total built-up area of 5.9 million meters squared of certified projects. With health and well-being becoming a major factor in green building industry, WELL standard has first been executed in the UAE in 2019, and 4,000 meters squared of built-up area in the UAE are readily certified under WELL. Building on the successful implementation of these regulations and initiatives, we believe that incorporating net zero principles within the current building regulations can support the government in achieving its vision towards decarbonization. In order to support the net zero movement in the UAE, Emirates Green Building Council evaluated a number of case studies and obtained data on the performance of key design projects in the UAE. The results are presented in these graphs for villa and office projects. The red bars represent the design energy use intensity, while the green ones represent the EPIs, or the renewable energy generation index, renewable energy generated per meter squared. As observed, the values of the EUIs for villa projects ranged between 44 to 120 kilowatt hour per meter squared, with a median EUI around 100 kilowatt hours per meter squared. On the other hand, the EPI for villa projects ranged between 0, no renewable energy generated on site, to 115 kilowatt hours per meter squared. We've also noticed similar results with the office projects for EUI values. These results demonstrate that several concepts, including nearly zero, net zero, where the energy consumption is equal to the energy generation, or net positive even, residential and office buildings already exist or are under construction in the UAE. In order to measure the market perception for nearly zero energy buildings, we've conducted a nearly zero energy building survey in 2017 to evaluate the position of the market and the views of different stakeholders, including government, consultants, and academia. At that time, stakeholders agreed that the UAE market is ready for a nearly zero energy strategy, with 27% answering that it should be implemented by 2020, while 44% agreeing on 2030. These results demonstrate a substantial potential for a successful launch and implementation of the nearly zero energy strategy in the UAE in the near future, in the coming 10 years as a maximum. It is important to select which building typology is best to implement a nearly zero energy strategy, as it could potentially affect the definition and the EUI target. It was indicated that through 49% of the survey responses that government buildings are the best building typology to implement a nearly zero energy strategy in the UAE. The survey feedback also indicates that apart from government buildings, residential villas and low and medium rise buildings are also suitable typologies for implementation of the strategy. As you know, there are over 500 high-rise buildings in Dubai, and it becomes essential to determine whether a nearly zero energy strategy can be applied to them. As seen from the figure on the right, the respondents were divided in their views, with 47% agreeing that a nearly zero energy strategy can be applied to high-rise buildings, while 40% disagreeing. Therefore, it can be concluded that there is no clear agreement of whether high-rise buildings in the UAE can meet a nearly zero energy definition. We've also asked the stakeholders about the right EUI target for net zero buildings. As illustrated in this figure, nearly all the respondents answered that the EUI target should be below 130 kilowatt hours per meter squared. This result is consistent with the findings from the case studies, where it was also observed that both residential villa projects and office projects have an EUI less than 130 kilowatt hours per meter squared. Hence, and based on the feedback we've received from the industry, we found that early adopters of the concept of nearly zero energy buildings in the UAE already exist. This validates that the time is appropriate to transition from an early adopter state to mainstream adoption. Stakeholders agree that the market will be ready for adoption between 2020 to 2030. It is recommended to start with introducing the concept in the private sector in the public sector before the private sector. Cost was also identified as an important consideration for nearly zero energy buildings or any nearly zero energy building action plan. The action plan should be cost effective and hence focus on aggressive passive design measures, similar to strategies adopted by many EU member states. And based on the large number of high-rise buildings in the UAE, it is recommended to consider renewable energy beyond the plot boundary within the nearly zero energy building consideration. This can take the form of district renewable energy systems or potentially extend to regulated renewable energy certificates. In 2018, and to support the net zero movement in the UAE, we've partnered with the International Living Future Institute to deliver zero energy and zero carbon building certifications in the UAE. The ILFI definitions for zero energy and zero carbon were adapted based on our definition and based on the applicability of the ILFI criteria in the UAE. According to the definitions, a zero energy building is a building that generates 100% of its energy needs through on-site renewable energy. Off-site renewables can be considered in some cases, such as where there is no interest from project owner to install PV if a tenant is considering a zero energy certification. Off-site renewables can be considered for buildings with high baseline EUIs, or in cases where there are grid limitations. A zero carbon building requires also meeting 100% of the annual energy demand through renewable energy. However, it provides more flexibility in terms of using off-site renewable energy. Here are some additional requirements for the zero carbon building certification. The certification requires an EUI target, an energy use intensity target for new and existing buildings. For new buildings, the EUI target is 100 kilowatt hours per meter squared per year, while existing buildings must achieve a 30% reduction on the local median targets presented in the second table. For instance, a zero carbon existing school should have an EUI less than 94 kilowatt hours per meter squared. For other building typologies, the building must demonstrate a 30% reduction in energy use compared to a typical building of its type through the zero tool. Moreover, for new buildings, the zero carbon building certification require a reduction of 10% of the total embodied carbon compared to a baseline, and should achieve a total embodied carbon less than 500 kilograms CO2 equivalent per meter squared that is offset through carbon credits such as CERs. To learn more about the certifications, please contact us at netzero@emiratesgbc.org. At last, I would like to share with you two case studies for projects in the UAE registered for the zero energy and the zero carbon certifications. The first building is the Tilal Al-Jaf Sales and Experience Center by Majid Al Futtaim. The center is situated at the heart of Tilal Al-Jaf community. It has a curved shaped roof, as you can see in this picture, which incorporates photovoltaic panels. And it has also a raised ground plane, which provides a transparent gathering space open to the nearby green landscape. The renewable energy generated on site is greater than the annual energy consumption, which makes building net positive energy. The project team aims to achieve the ILFI Zero Energy Building Certification, WELL Building Standard, and BREEAM Excellent. The glass facades were oriented to minimize the solar heat gain. The offices in the building are positioned to avoid excessive heat gain during the day. And the building is mechanically ventilated to provide a comfortable indoor environment, while indoor office spaces has been designed to be naturally ventilated by opening doors and windows. With regards to the building envelope, the facade is thermally insulated with U values of 0.42 and 0.3 for walls and roof, respectively. The PV system installed on the roof and the parking area produces more than 200% of the total amount of the energy demand, and the surplus energy is fed back to the grid, the DEWA grid. The project will be audited for the zero energy certification after a completion of 1 year of occupancy, and hopefully will audit this project and certify it in 2021. The second case study is C Institute by Diamond Developers, which is located in the Sustainable City. The Institute aims to promote knowledge in sustainability and built environment. The project is currently under construction and aims to achieve the net zero carbon building certification. The project team is focusing on reducing the embodied carbon requirements of the building following the ILFI recommendations and requirements, which are 10% reduction of embodied carbon and a maximum limit of 500 kilograms for the total embodied carbon. To achieve this, diamond developers are considering several strategies, such as optimized structural design to reduce the amount of building materials used, low carbon and locally sourced materials, prefabricated elements such as hollow core slabs, and lightweight facades. Regarding the operational carbon requirement, the project team aims to achieve an EUI less than 101 kilowatt hours per meter squared, and to cover all of its energy needs using solar energy generated on site. The project team is also considering a unique approach to use the surplus renewable energy by offsetting a part of its embodied carbon through this renewable energy generation. To achieve the energy efficiency levels, they are also considering both active and passive design measures. For cooling, the building will use an efficient VRF system combined with biogas. The building will be audited for the zero carbon certification in 2022 and hopefully certified by that time.
Just 1 minute, Maj.
Yes. So at last, I encourage you all to check our website and check our Net Zero Center of Excellence page to learn more about the Net Zero movement in the UAE. You can also download the reports, our reports defining nearly zero energy buildings in the UAE, and our benchmarking reports. You can also check one-click LCA Planetary, which is an embodied carbon tool that is offered for free for companies in the UAE as part of our partnership with Bionova. Thank you, and please feel free to reach out if you have any questions.
Thanks for that. That's brilliant, Maj. That was Maj Fayyad from the Emirates Green Building Council. I'm sure you'll agree to great case studies of net zero projects, and good to hear about those certifications and initiatives to reduce the carbon footprint in buildings. So on a similar theme, I'd like to introduce our speaker from Multiplex, who'll be presenting some of his case studies of Multiplex's projects of a near zero staff accommodation, as well as some other projects. So please, would you be able to start your presentation, Johan, if you can share your screen? Just
Thank you,
one more reminder just to everyone to please turn off your cameras. There was a Colin and someone else who had their camera on. Sorry about
that. Julian, can you see my screen?
Yeah, that's great.
All right, I'll just turn the camera on. Yeah. Good afternoon, everyone. Thank you, CIBSE UAE, for hosting this conference. This is the first one, and we're really proud to be here as well, participating in this one on a very important dialogue of net zero. Historically, our industry, construction industry, has always been known to be a few years behind time, and we should be really proud that the whole concept of net zero has been introduced by the construction industry to the world right now, and everyone seems to be adopting it. With the 2020 pandemic that has hit us, it has given us a lot more opportunity and momentum to only start putting these plans into action following the IPCC 2018 report. And I believe everyone here who's presenting is already on it, and people who are here are planning to get on it. So it is great to see that we should start putting these things in action. Through my presentation, what I'm going to go through is Multiplex is a construction firm. We build to survive, to be honest, and green buildings is our specialty. And that has always been our focus. We're a global contracting firm. However, with the changing times and the scenarios that we're around, each organization needs to take radical steps to move towards a higher energy efficient and operational efficient approach. And that's exactly where we were in 2015 at the cusp of the curve. And today, from where I started to where we are, it's been a great learning for us as well. And we're well on the journey of net zero. So I'm just going to introduce Multiplex globally and show how we, throughout not just the Middle East region, but throughout the other 3 regions, are getting on the net zero and the climate action plan. In 2018, July, Multiplex Europe committed to the science-based targets. Science-based targets is a greenhouse gas emission reduction target. It's a public commitment that you make to reduce your carbon footprint in the next 15 years. So in July 2018, Multiplex Europe did that. In September 2019, Multiplex Middle East was given the task to come up with targets and have a reduction strategy ready for the next 15 years. So in 2019, we did that. And in 2019, November, we also convinced Canada, Multiplex Canada, to sign up to the science-based targets. So our umbrella for reducing our carbon emissions is the science-based targets, and that's the drive. We've also been bound by the World Green Building Council net zero commitment. However, it's the journey that started way before 2018, because the data and the approach that you take as an organization and the fights that you have to come across within the company have made us reach this stage, but the journey started a lot earlier than 2018. So in 2018, Multiplex Middle East developed an in-house greenhouse gas emission calculator. I'll run through each of the scopes. Basically, all your emissions are divided into 3 scopes. Scope 1 and Scope 2 are technically your direct emissions that are within the control of your company. And Scope 3 are the indirect emissions, which are, I wouldn't say, it's more on it depends a lot on the supply chain and your collaborations and the whole supply chain and the stakeholders that you work with. So it's a lot more not reliant and in your control from the start. So Scope 1, I've just put a number here which says 37,518 tons of CO2. For a lot of you, it may not make too much sense, but if I were to put it in cost, Multiplex in 2018 spent around 35 million dirhams just on fuel, and the 37,000 tons of CO2 that you see is equivalent to the fuel that we have consumed in 2018. So there was a massive opportunity for us to focus on reducing this, and this we came up with a strategy, something that not a lot of people are aware of, not coming from a construction background, is that in the Middle East, throughout your construction of a project, I've just put in a project on the right, you can see it's a Jumeirah Gate project on JBR. So throughout the life cycle of a project, the company is not allowed to tap into the main grid. So entire construction of your 2 to 4 to 5 years of the project has to be done on diesel or an alternate source. So you can imagine the number of emissions coming out of the number of buildings that are in the Middle East in construction. In 2017, we had around 28,000 construction active construction sites in UAE. So the concept of implementing our understanding of building green buildings and transforming it into temporary site offices to build or for a project like I've just showed you is something that we emphasized on, and we decided to model a typical conventional site office that we find on every project, where you have portable cabins stacked up with no or minimum insulation, cheap air conditioners that have been put in, no focus on lighting, no focus on how your energy is going to be managed here. So on the left, you see it's an actual site office from the project, and we tried to model it, and our aim was to see if we can reach a nearly zero target as described by Marge on the previous presentation. So our target was to hit, our target was to hit 90 EUI. So our focus basically went on the external walls, the roofs, the ground slab, which is something that not a lot of projects also, forget temporary structures, but projects also don't insulate. Obviously lighting, we wanted to design our lighting in a temporary office through ASHRAE guidelines. We wanted to put up energy efficient HVAC units with 5-star rated and inverter systems. And we had a little bit of a focus on our air infiltration as well on every exits. So putting in those parameters and adding a bit of insulation and playing around with the permutation combinations, we reached a certain amount. We reached a certain amount of percentage improvements on each and every parameter. I'm not going to go all through by it, but I'll just say we insulated the walls to 100 mm insulation. We insulated the roof to 75 mm insulation. Likewise, the ground floor slab. We would have clear glass windows, so we introduced double glazed units, and we changed the HVAC, the temporary cooling systems to 5-star ACs. We also implemented a CFD analysis of the model where we would have a consistent flow of air throughout the office and not just on the corners where the air conditioners are. So that also helped us in reducing our energy consumptions. The study was only on paper. Let me please clarify that first, that this was just a case study on paper. It had an incremental cost of around 375,000 dirhams of implementing active and passive measures. We did come across with huge energy savings over a period of 2 years, which is a normal operational period of any construction site office. And the total cost savings that we associate to the energy savings was around 485,000 with a cumulative payback of 9.5 months. Now, so this was the journey that we started. We took the baseline, which was a conventional site office of 255 kilowatt hours per meter square EUI. And then through our passive designs and active designs, we managed to reach around 152. While you see we were still off the target, and then we integrated solar PVs to reach around 77 and below the Gbci nearly zero target. Now that was on paper. This is where the interesting part comes in. We actually implemented those principles on an actual site office, which is in Tilal Al Ghaf as well. What you can see on the left is a conventional site office. When I first joined Multiplex in 2015, we were consuming around 350 kilowatt hour per meter square. And today, in the 5 years and 5.5 years of us being here, we've managed to reach 56 kilowatt hour per meter square with a good amount of savings. I will come to the cost and the operational cost now. You can see the dirhams per meter square that we spent was around 550 for a conventional site office. And for a nearly zero, what we are operating right now is at 53%, so almost 90% reduction. These are the reduction in our emissions once we have implemented these strategies. So we've reduced our operational cost by around 6%, and we've reduced our energy emissions by 3,500 tons of CO2. I don't have time for this one, so thank you, Julian. I'll just, this paper is available as well. I'll share it with Julian, and it can go to the rest of the crowd as well. Thank you.
Yeah, that's great. Thanks, Johan. Thanks for wrapping up so promptly as well. As you said, we can share all these papers, and there'll be a summary paper at the end, produced at the end of the conference tomorrow. So thanks for sharing Multiplex's approach and what it's doing to meet those net zero targets, and good case study of near zero staff accommodation. Very interesting. So next we have Marwan Zaidan. He will be representing Schneider Electric, and he's the director in real estate and healthcare. So it's similar. It's Schneider Electric's approach to net zero through digitization and the Internet of Things, and how this could be pivotal in integrating buildings, transport, and urban planning in low carbon. So please, if Azra is ready to start sharing Marwan's presentation.
Hello, everyone. My name is Marwan Zaidan, and I am leading the real estate and healthcare segments at Schneider Electric across Middle East and Africa. It's quite a pleasure to be participating at this event, and the topic of net zero is quite a crucial one. For sure, it's a topic that we can spend a lot of time on, but I will focus on the key messages to stay within my time limit today. Do take note of my contact details, and please feel free to reach out. Now, many cities are already having commitments to reduce climate change, and some have progressed towards reducing their carbon emissions. However, we still have quite a long way to go. With climate change accelerating, we need to take action. And we do know that buildings are the major consumers of energy in a city, and they are the biggest contributors to greenhouse gas emissions. So for sure, focusing on buildings in a city will give us a lot of positive impact. There are two key trends that help us achieve better buildings towards the path to net zero: digitization and electrification. Digitization is where we leverage digital solutions such as Internet of Things, IoT, big data, artificial intelligence, or even machine learning. And these will help us make buildings much better. Electrification is driving a dramatic shift to more renewable sources for electrical generation, such as wind or solar. And these will help us decrease our dependence on fossil fuels. So really, how do we achieve this? With digitization, we leverage the Internet of Things. The first important thing to note is that we can also apply this for the existing buildings, or what we call the brownfield. While I might not be able to retrofit everything because it will be too costly, what I can do is deploy sensors, for one, to help me get additional data, and I can do small integrations and small additions with things like gateways. For greenfield buildings or new buildings, for sure, I can do more. And here I can deploy what we call connected products or digital products. These are products that have embedded sensors in them and are able to give me a lot of information on their own health, their own environment, and the overall system that they are in. What is going to happen is I will get a massive amount of data being generated from the different systems, the different products related to the overall areas in the building, as well as the people in the building using them. Then what I need to do is to use solutions around big data and artificial intelligence and machine learning. And what these solutions will help me do is digest this massive amount of data and find the right correlations between them and transform the data into actionable insight. And then if I can tie my building information modeling solutions, my BIM, with my building systems and my building management system, I can really get the full view of the different systems, the environment, and that information will be translated into actions that helps me reduce my energy consumption. But more importantly, it will help me increase the comfort for the people and help them have much better quality of services, because this is quite crucial. While the aim is to reduce energy, I want to make sure that this building is a much better building for the people using it. I can also start to predict maintenance issues and address issues before they occur. With this, we get a much smarter environment and much more desirable building to be in. Then I integrate renewable energy sources such as solar or wind with a mixture of storage, because active energy management is quite important, and I need to make sure to be able to balance my loads throughout the day, throughout the seasons. And I can do this by being able to anticipate my generation. So think about weather conditions that would really impact the ability to generate from solar, with the ability to anticipate my consumptions, and then trying to manage the environment in an active way to maintain lower peaks and to make sure the consumptions are spread. Hopefully, and at certain times, I will have what we call positive energy. This is where my building is generating more power than what I'm currently consuming. And what I can do is either feed that back to the main grid or store it in my energy storage. It's really important throughout the cycle and at the start of the cycle to have the right regulatory framework, and if it's applicable, the corporate policy, because that will be the right starting point for what I'm doing. Plus, it will give me the right ESG, my environmental, social, and governance performance metrics in place, so that I set my targets, I monitor them in real time, and then quite importantly, I can go back and fine tune if needed, because I might not get it right at the beginning, but as long as I can monitor and fine tune, I can make sure I continuously optimize so that my environment is running as perfect as possible. There is quite an interconnected stakeholder matrix involved. And again, we don't have a lot of time to go through them in details, but it's quite important to establish that collaboration between those different stakeholders which fall in the different timelines of the building. And this will be quite important to help me achieve my net zero. Initially, as we said, we need to start on the design side, and the design side will basically take input from the framework or the corporate policy that we have in place. And for sure, there is no denying that we need to put a little bit more thought and effort in the design side, but that effort will translate quite well in my ability to achieve a better ROI over the life cycle of my building. These designs will help me decide on the types of products that I need, from sensors to meters to their control. It will also help me avoid silos inside the building, so I make sure I leverage this investment to the maximum extent possible. And then it will help me identify the right components I need and the solutions for analytics, for machine learning, and for artificial intelligence. All of these will then drive my entire value, the value-based maintenance that I get inside the building, and help me drive the right automation needed and the operational intelligence which is required. And then I do real-time monitoring throughout that building. And as I mentioned before, that real-time monitoring and the metrics that I'm looking for will then feed into the cycle so that I continuously fine-tune and I continuously aim for a building that is as optimal as possible in its operations. You will see on the right-hand side the different standards and the different certifications that this building may want to aim for. And this reporting will help me measure and make sure I confirm with them. And I will conclude with a nice example, because of course, without examples, all what we've talked about remains to be pure theory. Intensity in Grenoble, France is a great one. It's one of our most recent examples. This is a set of 4 blocks, which is close to finalization, so it's not quite operational yet. It's spread across 26,000 square meters, and it's meant to host 1,600 employees. We worked on the designs from the early point. It's meant to achieve LEED Platinum in design and construction. The set of buildings are aiming for a very low average consumption of 37 kilowatt hour per square meters. And this is really low, because if you compare it to our typical building, it will be 10 times as much. In order to offset that, we've deployed 4,000 square meters of photovoltaic panels combined with 2 wind turbines, and those will generate around 970 megawatt hours per year. If you do your maths, you will see that overall it is net zero. The building is autonomous, but of course, because we need to be able to manage that generation with the consumption, we've deployed 300 kilowatt of energy storage, and there's a microgrid overall. Now, the building will be net zero for sure. It is an office building, so I don't just want it to be a net zero. I want it to be a very productive building as well. And this is why we're leveraging the same set of digital solutions to help me optimize the performance of this building. So for example, I'm continuously monitoring the air quality to make sure it's quite high. I'm able to monitor the assets and their health inside the building so that if something is going to break, I can fix it before an issue happens. I'm providing my employees with tools to do things like room bookings, wayfinding, for them to be as optimal as possible. And I'm also managing the loads, managing the consumptions actively. So for example, if there's a meeting room that is not occupied, I reduce the consumption in it. And I'm continuously monitoring all of the environment to make sure it's quite optimal throughout. So this is quite important. I'm aiming for net zero, but at the same time, I want to make sure that this building is as productive and as comfortable for the employees as possible, and also as easy to maintain for my facility management team as possible. I really hope this was a beneficial session for you. I know we did not cover a lot, but we focused on the key messages. For this, please do feel free to find me on LinkedIn or to drop me an email. I'll be more than happy to interact further with you and to discuss this topic even more. Thank you so much for listening, and please enjoy the rest of the event. Thank you.
Thanks, Marwan. That was Marwan Zaidan from Schneider Electric. I'm sure you'll agree that was a fascinating insight into how Internet of Things and digital tools can be used to achieve those net zero goals. I can see there was a bit of healthy debate, shall we say, regarding the electrification and whether, you know, in terms of fossil fuels in usage in the grid, and I know it's been pointed out that there's a shift undergoing away from fossil fuels in the UAE towards renewables, etc. So yeah, carry on with those debates. That's good to see. Next, we have Inas Al-Khatib. She is a sustainability engineer and a HVAC designer from AME Design Group. It will be myself who shares this presentation at the moment, so you'll just have to bear with me 2 seconds. I know that the quality of audio isn't fantastic, but it's okay. Can you hear that?
I can't hear anything, Julian.
2 seconds. 2 seconds. Apologies for that. I know what I've done.
Hi, my name is Inas Al-Khatib. I'm a master graduate from British University in Dubai, and currently I'm working
Julian, we can't
in
see the
energy
slides.
design in California, United States, as an energy consultant. Okay.
You can't see the slides?
Yeah, now we can. Thank you.
You can, yeah. I thought so. Okay.
I once read an article titled Net Zero Energy Homes have arrived and shaking up the US housing market, and I was really impressed and inspired by the information. The article mentioned that the US will have 5,000 zero energy single homes by 2018, and California by itself will provide 100,000 homes a year. Reading this information made me realize that this could be also doable in the United Arab Emirates. I was inspired to provide a paper that would encourage the local market in the UAE, the support of the government to transform the existing building into net zero energy buildings. The latest statistics of 2013 showed that around 80% of the produced energy in the UAE is still consumed by buildings. Specifically, we're talking about the existing building, which form the majority of the built environment in the UAE. And I remember, I recall that in ARENA, Remap UAE report 2015, the total energy used for the building sector was 0.2 exajoule, with the majority from the electricity use, and it was expected to reach 0.5 by 2020 and 0.7 by 2030. Although the UAE local region had witnessed several studies that evaluate the retrofit measure and their impacts in reducing energy and their feasibility, but there are no studies on the impact of a holistic retrofit approach that minimizes the energy demand to the lowest level before providing PV and that could eventually supplied by on-site renewable energy. And I hope this study will fill the missing gap. The Ministry of Infrastructure Development in Ras Al Khaimah has been chosen as a case study for multiple reasons. First one, for its for the size, for the building size, it's a modest size, and it will suit the time frame for the study. And number two, and this is I think the most important thing, that the previous study has been conducted on this building to evaluate the lighting system retrofit, and the result of that previous study will be used and include into my study to form a complete overview for a holistic retrofit projects, which is needed before any installation for a renewable energy system. And finally, I believe by choosing a federal building for a holistic retrofit, a broader message of the country's vision towards sustainability will be delivered across the country, which may increase the awareness of the private sector as well as individual towards the benefits of the building retrofit. An energy modeling simulation method is used to evaluate the impact of all the implemented strategies, and of course at the start of this research for that building has been simulated as business as usual and used this baseline as a reference to all other scenarios. To validate this software, after this building has been simulated, business as usual, the result compared to electricity bills for 2015. Different measures were implemented. Different scenarios were devised in order to assess the impact of the implemented measures. These configurations were grouped into 3 categories: baseline, passive measures, and active measures. And as I said before, the first category, the baseline, will be used as a reference for all other measures to scenarios to be compared to. Here we can see the impact of each passive measure in reducing energy consumption, and we can tell that passive house regulation with double glazing and solar heat gain coefficient 0.2 is the most efficient as a passive strategy in reducing the total system energy consumption by 15.3%. By considering a couple of passive together to form an optimal scenario, the reduction in HVAC system reached 18.7%, and in electricity consumption, the reduction was 14.7%. Active measures, 2 active measures, reducing the internal cooling load and upgrading the HVAC coefficient system, both of them, they provide a very impressive result. Combining passive and active to form an optimal retrofit also the result was really encouraging, and the cooling system reduced by 83%, and the electricity reduction was 65%. And before starting the PV installation or assessing the PV supply energy, we need to include the result of the previous study that's done by Al-Awadi. This study shows that lighting electricity could be reduced by 25% if daylight sensors and dimming system were provided. And thus, the total electricity consumption after considering all the retrofit action is equal to 169 megawatt hour. So the demand is 169, and this needs to be supplied by PV panels. The PV categories focus on different technologies and the required areas to achieve it, and it found that following the absolute PV approach would allow the utilization of the maximum area of this of the roof, and this could produce more solar energy regardless of the lack of the south optimal orientation. Also, 2 configurations were introduced, the monocrystalline and the polycrystalline. The monocrystalline is more efficient, however, the polycrystalline is more economical. And using monocrystalline, the result will meet and even meet our goal and transfer our building to net zero energy building. However, in case of using polycrystalline, more area to install PVs is required. To add more PV panels, a thorough analysis was conducted to the building site, and it was found that the parking lot, the orientation of the parking lot is very promising to provide a suitable area to add PV panels. And the row that's highlighted by red, it shows that 16 cars, the shading for 16 cars could offer 220 square meter for monocrystalline PVs. By adding this PVs, this will transform our building to net zero electricity building by using polycrystalline PV panels. To conclude, regarding this specific building, active measures prove to be more effective in reducing electricity consumption. In case of using polycrystalline PV panels, more areas is required to reach our goal, which is transforming the building to net zero electricity building. Monocrystalline is more effective with limited areas, and it's recommended to be used in the case of multi-story governmental or federal buildings with high internal gain. And actually, it's really neat to understand the building's full potential. This is very important to increase the PV areas, especially I'm talking about multi-story building. For example, utilizing the facades with the proper orientation to upgrade PVs is one approach. Shading elements for the east, west, and south-oriented windows could be also another approach, and etc. And I would like to close with this sentence, lead by example. It's very important to show the impact of extensive retrofit approach, which consider renewable energy. The benefits are huge, and I believe the government should consider a certain percentage of their electricity source in both federal and governmental buildings to be derived from solar PV. This could set an example to influence a broad segment of private building sectors. And finally, net zero buildings are the step towards a better future. Thank you very much. And please, if you have any question, any comment, any feedback, my email is there. I would love to receive your comments. Thank you so much.
Okay, so thanks, Inas. That's Inas Al-Khatib from AME Design Group. A very thorough presentation highlighting the benefits of retrofit approaches. Next up, we're a couple of minutes overrunning, but next up we have Karam El-Jazir. He's Chief Sustainability Officer at Diamond Developer, and he will be covering above all a case study of UAE's sustainable city. So looking forward to that. Karim, I think you may be on mute.
There we go. Thank you, Julian. And so I just shared the slides. All good?
Yeah, that's it. Great.
All right, very good. So thank you for the opportunity. Yes, I am based in the sustainable city since 2016, and will bring some insights into how we have approached the net zero energy goal that we have set for the community. And I will also conclude with a couple of slides on how we can go from net zero energy to net zero carbon. And apologies if I come through a little bit choppy. The connection has been a bit difficult. So please bear with me. Thank you. So for those of you who don't know, briefly, the Sustainable City is a master planned community located in Dubai land. It spans 46 hectares, about 1 kilometer long, about a kilometer long and half a kilometer wide. And it is from the get-go, our goal was to really embrace the 3 pillars of sustainability. So we want to be socially, environmentally, and economically sustainable. In terms of built-up area, we talk about 2.5 million square feet distributed across 500 villas, 89 apartments, a mixed-use development, and some non-residential developments and facilities such as equestrian, a school, an autism village, and an institute. And so we also have a buffer around the community which traces the boundary. And today, 5 years on, we are a proof of concept when it comes to demonstrating how to live, work, and thrive in a low carbon and resilient community. The master plan, this is what you see. The legend you can look at, at your ease. These are the 5 clusters. You notice a spine right across the middle of the development and a buffer zone around it. Everything you see has been implemented except for number 11 on the left side, and that is the Sea Institute, which is currently under construction and was mentioned as a case study by Gbci just a while ago. All right, so what have we done, from the get-go to achieving net zero? So today, hindsight is always 2020. So we know very much what is the approach. I believe all the previous speakers touched upon the same. So when the goal is to achieve net zero, it has to be a two-pronged approach. On the left side, it is about reducing demand. So what can we do to aggressively reduce demand, whether through active or passive design features? On the right side, after having reduced our demand, how can I offset all of that demand from renewable energy, whether up to 100% or any other percentage uptake? So 2 things that we have to achieve at the level of the community. So I'm going to start with the passive design, which supports demand side management. And the first thing to do is for new developments, this doesn't apply to existing developments, but anything new, and there is so much construction still happening in the GCC and will continue, we need to avoid the sun in this part of the world. In Poland and Scandinavia, they would do the opposite, which is to embrace the sun. And on these pictures, you see on the left how we avoid the sun simply through orientation. So we have south-facing walls, which are well insulated and closed. North-facing walls, which also trend east and west, have balconies and windows and to provide daylight, of course, and the gardens. Notice the rooftops, that's the solar canopy, which is also part of the architectural design. So that is step number 1. Step number 2 is the active design. So what can I do to bring down my consumption? And these are the 5 boxes that we tick. The first one is about insulation, and it all starts with insulation of the walls, the windows, and the roofs. If you look at the table on the right side, you're going to see those 3 elements. You're going to see the Green Building Regulation Standard U values. That is column number 3. For example, windows, if we just follow the Green Building Standard, we need to achieve a U value of 2.1. And the last column is the sustainable city. The lower the U value, the better. In other words, less heat gains. So we have designed for and achieved 1.3, which is significantly lower than 2.1. The walls is 0.32, which is also significantly lower than 0.57. So that's item number 1. Then it becomes cheaper or less expensive. Then we need to integrate efficient air conditioning, be it district cooling, but in our case, it's VRF air conditioning. This was generation 4 by LG. We're now to generation 5. Energy efficient appliances in the kitchen. So all the kitchens are fitted and we know exactly what is the amount of electricity or the connected load needed. And then we have LED lighting throughout the homes and the community, and we have solar water heating on the rooftops. Now, in hindsight, we're also trying to, we are exploring and have tested thermodynamic water heating, which is also novel, energy efficient, and less space demanding. The result of all of that is that the villas in the sustainable city are able to reduce their energy demand by as much as 40% compared to anything conventional in the immediate vicinity here in Dubai. And the measured energy use intensity achieved, in other words, was 95. Our design was to achieve 90, so we're very close to achieving that. I believe to go from 100 to 95 or from 95 to 90, it's also about behavior change. It's not only about insulation and technology. After concluding that piece, which was about reducing consumption, we now want to increase production. And through the Shams Dubai initiative, the Dubai Electricity and Water Authority enabled net metering to all households and building owners since 2014, and that is Executive Council Resolution 49. So far, based on energy modeling the entire community, we estimate we need 16,000 megawatt hour per year, or 16 million kilowatt hour. To produce that, we need to deploy 10 megawatts peak because the ratio is 1600 to 1 kilowatt hour to kilowatt peak. So far, we've deployed 8.2 megawatt peak on communal and residential rooftops. Here on the right, you see some of the vendors. We like to mention those, whether we talk about the inverters, SMA, CACO, Fronius, ABB, or PV modules from Trina Solar, Jinko, and also LG. And this is an aerial photo of the development. Now, sustainability is not only about reducing consumption through technology and producing energy through PV modules, it's also an attitude. And if we can convey and showcase the energy performance of these villas or other facilities to end users and tenants, we believe that we can educate and nudge people to practicing more energy efficient lifestyle. So sustainability is an attitude. These are devices we're able to deploy. In this case, it's called SMAPI, which at the palm of your hand on any smartphone, you can really track your energy profile. All these humps are the solar profile. This is in the summer. And then in blue, you have what we call standby or always connected loads, and such as Wi-Fi and signals, etc. And then in gray, these are all the other loads, mostly air conditioning. Lastly, what I want to say about this slide is that we're now entering that space of prosumers. Utilities should no longer look at consumers as people who simply import electricity and water. Consumers are also producers, and they can produce electricity, they can also produce drinking water. And so the mindset has to shift at the level of consumers and at the level of the utility. Communal PV, just a few pictures. We've deployed PV on the mixed use, parking areas, the school, etc. And so all the non-residential buildings have solar rooftops from school and Sanad Village and Sea Institute and parking areas. In 2019, we achieved 88% solar offset in common areas. And I'm going to show you another number for 2020 coming up.
Couple of minutes.
Okay. All right, and so just to show you, we need to document all of this, right? So when we talk about renewable energy and avoided carbon, we do have certifications. So we have certified emission reduction provided by Dubai Carbon according to an established methodology. And so in 2019, we avoided 3,033 tons. In 2020, we avoided 3,389 tons, and that's on the right side. And the small number you see below, this is the emission factor, which comes from electricity produced from DIWA or by DIWA. And the trend is going down, which means they are also becoming more efficient. The carbon footprint of grid electricity in Dubai has dropped. Lastly, just how to go from net zero energy to net zero carbon, because this is the challenge for all of us. Embodied carbon is perhaps up to 50% of our emissions in the built environment. Two slides just to convey to you what the type of analysis that we perform. So this is now looking at facades for a non-commercial building. This is the Sea Institute. We looked at 6 different types of walls, from thermally insulated blocks, external insulated finishing system, precast, lightweight facade, etc. And then we do a comparison of the global warming potential, the U value, the acoustic value, and the total loads. And so here the selection is on Saint-Gobain lightweight facade, where I have a check mark because they achieve the lowest U value, not the lowest global warming potential. So we need to think embodied and operational carbon as well, but it is the lightest of them all, which means we also achieve savings in foundations, steel, and concrete. And lastly, this is my last slide, and this is very interesting. Hopefully we're contributing something novel to this conversation. What is the embodied carbon of renewable energy? So yes, we're very proud of going zero operational or zero carbon in operation, but how about a zero carbon embodied energy? And so here we did a life cycle analysis of a solar shaded car parking, and the donut you see on the left side shows you the embodied carbon of PV components, foundation, steel, and concrete. And on the right side, if you look at this table, this is a project of 214 kilowatt peak bifacial. So we can achieve about 1,700 kilowatt hour per kilowatt peak. The total embodied carbon is 450 tons. And if you divide that by the system size, we get an equivalent carbon footprint per kilowatt peak of installation. And that is about 2,000 kilograms. So that's a little bit concerning, because now, as we're very happy and excited about the renewable energy uptake, but we need to be mindful of the embodied carbon that comes with renewable energy. And to offset that, we need about 3 years simply to offset the embodied carbon of a solar shaded car park. Thank you very much. This is my email, and you're welcome to visit our community. Thank you, Julian.
Thanks, Karim. That's great to hear the developers' point of view and the developers' goals in how the developers meeting those net zero goals. I know that time marches on, so we're a few minutes. We're overrunning by a few minutes. But next we have Gbci, who is regional director of GBCI Middle East. So she'll be given a brief introduction to LED Zero and an incremental approach to net positive towards meeting climate emergency as a global agenda. So please, Gbci, if you're ready, go ahead.
Hello, everyone. Good day. Is my screen visible?
Yes, it is. You might want to minimize the Teams pop-up in the bottom right.
Yeah, is that okay now? Okay. So thanks to all our previous speakers for setting the stage for today's discussion. Thank you, Julian. My name is Gbci. I'm going to deep dive a little more into what net zero means to us at USGBC, GBCI, and to the vision of LEAD for the future. So the purpose of LEAD is market transformation. We continuously update the rating system as new technologies emerge and standard practice improves. This means that a LEED Platinum project in 2018 is much higher performing than a LEED Platinum project in 2008. In terms of LEED registered and certified projects in the Middle East, we can boast of nearly 2,100 plus projects. We have about 460 LEED certified projects ranging from data centers, healthcare, hospitality, schools, residential developments, malls, offices, industrial manufacturing, warehouses and distribution centers, etc. So we're observing increasing interest and participation in our LEED for Communities and Cities programs as well, which reiterates the fact that LEED works for all spaces. And the UAE is some of the top countries in the world for LEED, with over 60.6 million square feet of LEED registered and certified space. So where did we begin the journey here in the region? So in the UAE, some of the very first projects to be certified were the Pacific Controls building in Technopark, Metito headquarters, and the district cooling at Wafi, DCCP1. In Qatar, we have the Qatar Convention Center extension and RasGas headquarters way back in 2012. In Jordan, we have the Dutch Embassy, the WHO headquarters in Amman, followed by waterfront development by the United States government in Bahrain and the Al Arjan headquarters in Kuwait. Beirut City Center and International College Elementary School were some of the initial projects in Lebanon to certify. Oman paved the way for hospitality project certifications with Atana Musandam Resort in 2015, and PDO Oman certified their school. Saudi sees King Abdullah University of Science and Technology campus certified in 2009, while the Capsac Housing certified in 2012 and 13, Sabiq Academy certified in 2012. So many thanks to the contributions of all the project teams who've led the green building marketplace. With the work we do, we've seen tremendous interest, not just in LEED, our flagship rating system, but also across our platform of programs such as the performance-based platform ARC, and GBCI in the capacity of an independent certification body continues to support and enable TRUE, which is our net zero waste program, ParkSmart, Peer, Edge, GRESB, WELL, and CITES certifications in the region. So we're blessed to have all of you as our partners, and thank you for leading the green building movement in the region. Zero is USGBC's latest certification. It was launched in 2018 to help engage, inspire, and push our community and sector towards these critical goals. So LEED Zero is a complement to the holistic LEED certification. The goals of LEED Zero are to define and recognize leadership, inspire action, and greater achievement of net zero goals during building operations. With the introduction of our latest 4.1 LEED rating system, there has been changes been made to our energy and atmosphere category to be able to raise the bar in terms of energy performance, for which in the operational stages, USGBC has launched the version 4.1 of Operations and Maintenance Rating System that makes use of the ARC dashboard plugged in by the analytical platform on the back end that evaluates performance across 5 categories: energy, water, waste, transportation, and human experience. At a later stage, you'll also be able to track ESG metrics to a very large extent. We're offering 4 distinct LEED Zero certifications. They're all focused on operating performance and to verify the achievement of net zero goals over the last 12 months of building operations. Projects provide performance data for 12 consecutive months of operation. There are 2 minimum program requirements for LEED Zero. 1, the ability to provide 12 months of operating data, depending on the certification achieved previously. And the point number 2 would be previous LEED certification under BDC or O&M rating systems. LEED Zero Carbon recognizes buildings operating with net zero carbon emissions over the course of the past year. LEED Zero Carbon certification provides transparent accounting of the carbon balance, looking at carbon emissions generated from energy consumption and occupant transportation to carbon emissions avoided or offset. At present, LEED Zero Carbon program recognizes the following types of scenarios of carbon cost and carbon avoided: carbon emissions generated from energy consumption and occupant transportation to carbon emissions avoided or offset. USGBC intends to expand LEED Zero Carbon in the future to incorporate carbon cost from water consumption, waste generation, and the embodied carbon of materials used into the carbon balance. ARC calculates emissions based on project performance data that is uploaded onto the platform. Different regions have different energy sources and characteristics. Emissions rates vary by grid region. So, for example, the map from EPA shows E-grid by subregions. US EPA grid mix coefficients allow projects to convert their grid-sourced electricity into carbon emissions. This calculation is automatically offered while using the ARC platform. So to all those ARC users out there, you would have noticed that when you enter data into ARC, the grid emission factor by default is present in the platform to suit your region. So you also have the option of changing it if you feel that your building is, the grid emission factor for your building's geographic location is a bit different. Different modes of transport have different carbon footprints associated with them. For example, walking, biking, telecommuting have 0 carbon emissions associated with them. A single person using a car creates the highest carbon footprint amongst all modes of transportation. Projects administer a transportation survey to building occupants to understand how they're getting into the building and distance traveled. And then ARC calculates emissions from transportation based on this accurate information. The project team must conduct at least 1 occupant transportation survey during the 365-day performance period. Now we'll take a look at LEED Zero Energy, which recognizes buildings that achieve a source energy use balance for the past year. Buildings use different mixes of fuel types and energy source to meet their heating and cooling electricity requirements. Similar to LEED Zero Carbon balance, the total energy consumed is accounted for on the energy delivered side of the equation. On the energy display side of the equation, we're looking at renewable energy generated on site and exported to the grid, or off-site renewable energy procurement. Our buildings consume energy from different sources. The same building has multiple ways of combining these energy sources. So we have on-site natural gas combustion using boilers, renewables, grid electricity, district chilled water, district steam, and other fuels such as district hot water, chilled water, etc., which may not be regionally 100% applicable, but this nevertheless gives you a holistic view. So ARC applies a site to source energy conversion factor to translate site energy consumption to source energy values. The source energy metric provides an equitable comparison for project types using diverse fuel sources. This in turn helps teams to understand the impact of their energy use beyond the project boundary. For example, electricity has a number of generation, transmission, and distribution losses that are not captured in the site electricity use. On-site generation and consumption is always 1 because there is no site to source conversion. It does not cross the lead project boundary and there are no generation or transmission losses considered in this case specifically. But of course, as one of our previous speakers mentioned,
can you start to wrap up, please?
Yes. LEED Zero also recognizes on-site and off-site renewable energy consistent with the approach reflected in the LEED 4.1 as indicated in the program guide. Coming to LEED Zero Water recognizes buildings that achieve a potable water use balance of 0 for the past year. Water balance is equal to total potable water consumed minus total alternative water used plus water returned to original source. LEED Zero Waste certification recognizes buildings that achieve GBCI's True Zero Waste program certification at the platinum level. And to summarize, the LEED Zero program guide is now available on the LEED Zero website. You can contact us for more information. Quickly going into the certification process, projects register, provide documentation, sign the certification agreement. GBCI reviews the certification documents and announces certification. LEED Zero projects also use ARC to share performance data, utility bills, and supporting documents to achieve LEED Zero certification. LEED Zero carbon projects use ARC to administer the occupant and transportation survey. Our first LEED Zero energy project in the US was the Integrity headquarters. I'm not going to deep dive into the project specifics. We've also had a few more LEED Zero certified projects, including the Discovery Elementary located in Virginia. The first LEED Zero carbon building, which is the LEED O&M Platinum certified project, Hanergy Renewable Energy Center in China, and the LEED Zero Water project in Brazil, the Condomínio Commercial Euro Business project. In the UAE, we have seen tremendous interest for the LEED Zero program, and currently we have 2 projects participating in our program. Now, Marwan made a very important statement that he did not just want net zero, he wanted to go for net positive, and that certainly should be the goal to move towards LEED positive, the future vision of USGBC. Thank you, everyone. Please contact us for more information.
Thanks, Deepti. Thanks for that introduction to those LEED certifications, and it was good to see those examples both in Gulf countries and Middle Eastern countries at the start, but also those international examples and UAE. So without further ado, we're going to introduce Hassan Yunus. He is chair of ASHRAE Falcon, but he's also CEO and co-founder of GRFN, and he will cover a case study of a net zero energy school in the UAE. So please, Azra, you share the presentation.
CEO and founder of Griffin.
Yep.
Today we're going to be talking about a school that we've done energy modeling for, and then it was built, and we've done a study to turn that building into net zero. So these are the contents of the presentation. We're going to talk about the project overview, the building energy assessment, the site photovoltaics assessment, and then the simulation-based design versus net zero energy performance. So it's a school in Dubai, fuel type, it's electricity, floor area around 27,000 square meter, That's the air-conditioned area. Number of floors is G+3. Window fraction is around 30%. Building shape E-shaped. There were no skylights in the design of that building. There were some exterior shading devices to help reducing the solar gains. Floor to floor height around 4.5 meters for the ground and 4.2 meters for all the other floors. For the cooling system, the original design was AC air-cooled chillers. The net zero energy case, we have modeled a water-cooled chiller, a magnetic bearing water-cooled chiller. In both cases, there were variable primary, but in net zero energy case, the delta T was a little bit higher, mainly to reduce the pumping power. Now, looking at the building energy assessment, when we've done the design and when we've done actually the energy model, we were not the designers of the school, we were just doing energy model. And actually the design was already done when we've done the energy modeling, which was not the optimum case. We normally would tend to tell our clients that we should be engaged from the beginning, either doing the whole design and the energy modeling, or if we're just doing the energy modeling, should be engaged from day one to make sure that the design decisions are done in a way that does not increase energy consumption of the building. So we've done the energy modeling. I mean, we did have some input into the design, but it was almost a detailed design. We couldn't change, let's say, the shape of the building or window to ratio. These things were already done, but we did, let's say, improve a little bit on the efficiency of the HVAC systems. So we've done the energy modeling, and we've used, in this case, CIBSE, as can be seen from the model. And later, when the building was built, we did a comparison between the energy consumption that we got from the model and the energy bills, and we found that the patterns almost very similar. On this slide, we can see the weather data. I'm pretty sure everyone is familiar with the weather in Dubai. On this slide, we can see the U values and shading coefficient of the original design versus the net zero energy building case. In the original design, it's basically the Dubai municipality requirements, whereas with the net zero energy case, we've improved on the U values. We didn't go for very drastic changes, so we need to keep in mind when we're designing buildings, we don't want to go above and beyond certain levels where the cost of the building will become too high. So we're trying to see like what are the optimum U values to get the net zero and still not cost a lot of money. Here we can see the loads and occupancy and filtration. In terms of lighting, the original design had a lighting power density ranging between 7 and 18 watt per square meter. 18 basically, I think, was in the all-purpose room. Whereas with the net zero energy case, we were able to go down to 3 watt per square meter by using very high efficient LED lights with power over Ethernet and a very advanced lighting control that takes into account daylighting, occupancy, so on and so forth. As for the plug loads, the original design room watt per square meter was around 5 to 25. In the net zero energy case, we've used better equipment, so more efficient equipment, Energy Star rated, and the load reduced by around 25% on the plug loads. Occupancy was the same in both cases. Infiltration, it's semi-tight construction was used to determine the infiltration, and we've estimated around 0.1 air change per hour of infiltration because the building is supposed to be pressurized with outside air. This was the usage profiles that were used for the different loads. Obviously, during nighttime, there's little activity, and most of the load is happening between maybe 8 a.m. to 4 p.m. more or less. For the HVAC system setup, for the original design, it was using air-cooled screw chillers with a COP of 3.55 at AHRI conditions. For the net zero energy case, we're using magnetic bearing chillers with a much higher COP and a very good part load efficiency. For the chill water network, both are variable primary. The delta T for the original case was 5 degrees C. For the net zero energy option was 9 degrees C to reduce the pumping power. Fresh air or the outside air was as per ASHE 62.1 requirements. For the heat recovery, in the original case, the primary wheel had 70% sensible efficiency and 60% latent. Secondary wheel had 70%. For the net zero energy, the primary wheel had 80% sensible efficiency and 75% latent efficiency, and secondary wheel had an 8% sensible efficiency. System scheduling, the operating hours were followed as per the school, and the cooling set point was 24 degrees C. Here we can see the HVAC system setup. In both cases, the original design and the net zero energy case, we've used outside air handling units, double heat recovery, and fan coils to cool down the spaces. In the design case, original case, we had air-cooled chillers with variable primary system. Here we can see the configuration for the net zero energy case. For the air side, it's the same as the base case. The main difference would be the efficiencies of the heat recovery devices. For the cooling system, we are using magnetic bearing water-cooled chiller with variable frequency drives on all the components, chillers, pumps, whether it's the condenser or distribution pumps, and the cooling tower. We got the loads from IAS, but we have used our own developed software, which is basically a very complex Excel sheet that will come up with the consumption of every component on an hourly basis for the chiller plant based on the load profile and the outdoor air conditions. The end-use analysis for the base case shows a high consumption for the chiller plant, almost 53% of the consumption. Fan energy is around 7.3%, mainly because we're only using fan coils to cool down the building and a couple of FAHUs. And probably an office building using AHUs, the consumption for the fans will be a little bit higher. We have around 8.3% that is used for the heating, the domestic hot water and the pool, lighting around 16%, and plug loads around 15%. As a total energy consumption, it's around 3.1 million or 3.2 million kilowatt hours. As for the EUI, it's around 118 kilowatt hour per square meter per year, which is very close to the benchmark study that the Gbci has done a couple of years ago. Here we see the end-use analysis for the net zero energy case. In terms of percentages, it's almost the same, but if you look at the amounts here, they're drastically different. And we can see that the chiller plant consumption went down drastically between the two cases. The fan energy as well. You can see that the plug loads have increased in terms of percentage. They have decreased in terms of quantity, but they have increased in terms of percentage of the whole energy consumption over the year. The main differences here, so what are the main changes to the design? So we have the lighting, which went down drastically. We have the plug loads went down by almost 25%. And most of the savings are coming probably from the chiller plant, because we have a much higher efficient water-cooled magnetic bearing chiller. It's an all VFD plant, So there are VFDs on the condenser pumps, there are VFDs on the cooling tower, there are VFDs on the primary pumps, and we use an optimum control. So we did a research, an R&D project with one of the leading district cooling companies, and we came up with an algorithm basically to run the different components of a chiller plant in an optimum way based on the outdoor conditions. And this is what we've used in this particular simulation to get the energy consumption of the chiller plant. So as you can see, the consumption is almost half. The EUI dropped down from 118 to 54, so it's even less than half. And one of the other things that we've used, if we use ultra efficient motors, so we used ECM motors on the fan coils, so that drops the consumption of the fan coils drastically. Also on the FAHUs, we use ECM motors. Now, looking at the site, we looked at the location, obviously, to get the amount of available solar radiation. We know that Dubai has a lot of potential for solar, and we looked at the amount of usable area. So it's around 4,000 square meters that we can use on that school. So excluding the chiller yard area, most of the other areas can be used to provide, or where we can install PVs, basically. The assumption here is the inclination of around 23 degrees, and the efficiency of the model is around 20%. So this is the annual simulation for the original design. As you can see, obviously, the consumption increases from winter to summer, July and August, because the school is practically off. There's a minimal energy consumption, but in total, there's the consumption around the year is like around 3.2 million kWh, and the EUI is around 118. If we compare the energy consumption versus the PV generation, we can see that, yes, the PV can generate a good amount of electricity, but it's almost half of the energy required by the building. So relying only on PV, and as we've seen here, we kind of use most of the available space, and we use very efficient modules. We still cannot get to net zero energy building, so it's very important to look at every single system that consumes energy in the building and find a way to reduce it in a cost-effective way. So with the addition of PVs, we can reduce the EUI from 118 to 66, but like I mentioned before, it's just not enough to get to net zero energy building, and we have to look at different ways to reduce the energy consumption. This is the annual simulation, monthly simulation for the net zero energy case. There's a drastic improvement in the UI. There's a drop from 118 to 54. That's almost 60% reduction in energy consumption. And you can see the pattern. Obviously, we still have more consumption during the summer, but due to the high efficiency chiller plant, the increase in energy consumption between winter and summer is not that drastic. Overlaying the PV production versus the monthly energy consumption, we can see that many months the PV generation is more than the consumption, and overall they kind of balance throughout the year, and we get to a net zero energy building. So we can see here from this slide that the school becomes almost a net zero energy building. I mean, there's a little bit of extra consumption, which is kind of very minimal. So we can say that by applying these systems, by changing the envelope, by having especially the water-cooled efficient chiller plant, all VFD, ultra efficient motors, we can get to net zero. It's definitely, it's going to be a much costlier building to for the client, but I mean, if we really want to get to net zero, then these are the fundamental things that we need to change about the building design.
This is the last slide, and here we can see the comparison between the end-use analysis, end-user breakdown of the original case, which is the build case, versus the simulated net zero energy building case. And we can see there's a drastic reduction in cooling from an EUI of 62 kilowatt hour per square meter per year to 25. And that can be attributed to, first, reduction of the load. So why did the load reduce? One is better envelope. Second, reduced lighting load. Third, reduced motor load. And then we have used a much more efficient system, which is a magnetic, using magnetic bearing chillers with an all variable plant, so VFDs on all pumps, and a water cooled system with an optimum control system. This is what led to that drastic reduction in the cooling consumption. Now, if you look at the other systems, also we have a good amount of reduction. So we have used premium efficiency motors, we've used electronically commutated motors, we have used solar water heating, we have used better equipment in terms of plug loads, lighting. Also, we have much more efficient lighting. So all these things have contributed to the net zero, not only reduction in cooling, but all other systems together. And by using almost all available space for PV, we got to the net zero energy building. So there has to be a holistic approach. We can't just target one system or just add PVs to get to net zero energy building. We have to look at every system that we have in the building. And that does conclude my presentation. I would maybe add that in order to really answer the question if it's feasible or not, we probably need to do a life cycle cost, which was not covered in this presentation. Maybe for another presentation, we can.
Okay, I think that's it. Thanks, Hassan. Thanks for that lovely presentation. I know Hassan will be joining us as well for the panel discussion. Next up, we have Nazli, who's a sustainability manager at Majid Al Futtaim. So please, Nazli, if you're ready, can you start sharing your presentation? Hello, Nazli, are you there?
Hi, yes. So wait, I have a little bit of problem with uploading my slides. Just give me a moment, please.
No problem. No problem.
Yeah. Okay. Okay, something is happening.
It's just loading.
Can you see?
It's just whirring round, so give it a second. There. Yeah.
Okay. So it's there, right?
Yeah.
Okay, great. Thank you. Good afternoon, everyone. Today, I'm here to talk to you about climate risk and net positive at Majid Al Futtaim. And I have to say, I'm going to talk more from a strategic level. I think most of us agree with the fact that since beginning of the pandemic, life as we knew it doesn't exist anymore. Politics, finance, and business have been interrupted, which means business as usual cannot continue. And that's why companies came together through different platforms, such as World Economic Forum's The Great Reset, to rethink and manage consequences of pandemic. Now is a good time to change our mindset and create new metrics to measure what really matters to our environment and our communities.
Let's look at the global trends here. This was published by World Economic Forum. The global list, you can see the global risks by likelihood, which identifies the most likely and most impactful risks that could affect businesses globally. Notice how the environmental risks are at the highest in terms of likelihood and impact. What is important to note here is that the bulk of major perceived risks are environmental and societal, with business environment facing more and more risks. Adopting a strategic approach, sustainability is a way to help take part in reducing the environmental and societal impacts. And now Majid Al Futtaim. So how do we at Majid Al Futtaim contribute to reducing risks? So for those of you who don't know Majid Al Futtaim, we are a lifestyle conglomerate operating across 17 international markets with more than 43,000 employees, obtaining the highest credit rating, BBB, among privately held corporates in the region. And I have to say, even in 2020, with pandemic, we managed to maintain our triple rating. So for us at Majid Al Futtaim, sustainability is included as an item in business meetings and board reports to allow for discussion at all levels. We believe that embedding sustainability in the core of our daily operation and DNA is how we can achieve our ambitious commitment. We officially launched our strategy, Dare Today, Change Tomorrow, in 2018. I have to point out that this wasn't our first strategy, but it was the first across our operation. So throughout the process of creating our new strategy, we have ensured that our strategy is aligned with numerous global frameworks, such as the UN SDGs and UN Global Compact Principle. And if you see here, you can see that we contribute to 10 of the SDGs directly and to all of the SDGs indirectly. Our strategy has three focus areas: transforming lives, which is about the communities we serve; empowering our people, which is about our employees; and rethinking resources. So rethinking resources is about environment. So our sustainable finance, net positive commitment, climate adaptation, and circular economy sits under rethinking resources focus area. We have sustainable business commitment on a number of material issues which are common across the company, including health and well-being, local economic development, and customer experience. To ensure that we are moving into right direction in regards to our environmental commitments, such as net positive, well, the main one, net positive, in May 2019, Majid Al Futtaim listed the world's first benchmark corporate green sukuk, and the first green sukuk issued by a corporate in the region. Following the success of the first one, in October 2019, we issued our second benchmark size green sukuk. In preparation for the issue of the Green Sukuk, we established a Green Finance Framework and Green Finance Steering Committee, which oversees the selection of new and existing projects for the green portfolio. We also received low-risk ESG rating by Sustainalytics. Sustainalytics is independent ESG auditor and certifying that Majid Al Futtaim is at low risk of experiencing financial impact from ESG factors due to its effective management of ESG issues. Wait, how can I go next? Wait. Okay, so the issuance of Green Sukuk reaffirms our commitment to sustainable green projects that supports moving to a low carbon economy, and especially our net positive. So you can see here use of proceeds. The first one is green building. which, well, if you probably, most of you know, we have a policy since 2014 for all our new assets to be LEED Gold, BREEAM Very Good, Estigama 3-star or higher certified. We have, then the second one is renewable energy. Again, as most of you might know, we have commitment to have 5% for existing assets or 7.5% for new assets coming from renewable energies. Then the third one is sustainable water management, which, you know, it can be water recycling projects or investment in projects, technologies, projects or systems which will reduce the water consumption by at least 30%. And the last one is energy efficiency investment in technologies, products, and systems which will result as a minimum 20% reduction in energy. And as well as an example on this one, we are rolling out using CO2 as refrigerants in all our shopping malls. And last year we piloted the same at City Center Master. So today we have more than 30 certified green buildings across our operation, which are part of the Green Sukuk portfolio, and this translates to 2.6 million square meter of green assets. One of which is Tilal Al Gaf Sales Center, which is actually MAP's first net positive building as well. And as during our roadshow on Green Sukuk, we received a lot of queries from investors in regard to our data assurance. We appointed third-party last year, third-party auditors to do an assurance on environmental data. And actually, last year was the first year that we included this in our annual sustainability report. The other thing that we started doing, which is completely entwined with our net positive commitment, is climate-related risks. We started looking at this at the same time. Well, this was part of our strategy. But at the same time, when we started going to the roadshow for the Green Sukuk, we realized that a lot of the investors are asking us about this, about what we are doing about climate adaptation. So in 2019, we started doing a gap analysis on all our documents, specification, requirement for green for new assets to ensure that we have the right requirement in our documentation. And last year, we started carrying out a risk modeling, risk assessment modeling for all our existing assets, which actually finalized at the end of 2020. And now we are in the next phase, which is we are looking at the business risks, and we are aiming at including a TCFD recommendation within our annual sustainability report this year, which hopefully is going to be launched by June. And for those of you, if someone doesn't know what is TCFD, is the Task Force on Climate-Related Financial Disclosure. So moving to the next slide, so you can see, you can access all our information, all our data, reports since 2014. You can find them on Majid Al Futtaim website, sustainability page. More information on the Green Sukuk report can be found on the website as well, along with other thought leadership pieces such as the Roadmap to Circularity white paper, which discusses our newly launched circular economy strategy. And the other one is, for example, understanding embodied carbon. We started last year. We partnered with Ramboll, and we created a study on embodied carbon of my city center Mazda. And at the same time, actually now we are working with Gbci to create a case study. You can find literature on our net positive commitment as well on water and energy. And my last slide. So, and if you are interested, you can scan the QR code and access our sustainability report. This was for 2019, and the 2020 is coming up by June. Thank you very much for your time, and I think I was as quick as I could be, so you could catch up with your time. Thank you for your time. In case you have any question, please feel free to send an email to sustainability@map.ae, and we definitely get back to you. Thank you very much, Julian.
Thank you. Thanks, Nazli, and thanks for outlining Majid Al Futtaim's efforts to meet those net zero commitments and how you're meeting investor expectations. Good to hear. That brings a close to our planned presentations. Next up is our panel discussion. You'll have met some of the participants already, and that will be moderated by Azra Hussain. So thank you, Azra, and
thank you, Julian.
Welcome to all the panelists.
Thank you. Welcome, everyone. And wow, amazing research and very groundbreaking insights on academic trends, regulatory trends, and evidence-based research. So I'd like to welcome all of the speakers who are going to be joining us on the panel today. And we're essentially going to be talking about the role and the reality of net zero. And it seems quite pivotal and at perfect timing, because we have on the panel perspectives from the contractor, from the green building consultant, and the design consultant. So I'd like to welcome on stage or on virtual conference Miss Deepti KB from Gbci. Hi Deepti, how are you? Thank you. You're on mute. Okay. All right. Thank you. I'd like to welcome Johan Kama from Multiplex, who will be giving us a contractor's perspective. Hi. Good afternoon, Johan. How are you?
Thank you.
Great slide deck, by the way, earlier at the start of the presentation. So
thank you so much.
Yeah, we're hoping to hear some interesting insights on what kind of key challenges are faced by contractors in the UAE. And most importantly, Mr. Hassan Yunus from Griffin Consultants, fantastic slide deck on the Net Zero School. Congratulations on winning the Energy Retrofit Award by CIBSE UAE.
Actually, CIBSE UK, but thank you very much.
Yes, congratulations.
Thank you, thanks.
So I'm going to be just starting the panel with just a quick insight, going back to what was initially highlighted by Farah and Majd about the current state of the Arab region. Yes, the dialogue has become quite richer in the last few decades. We have new trends in regulation, especially drivers from the government, the local government authority, like demand side management, from the Dubai municipality and various other regulatory bodies like EHS Tarakis, Estidama, setting forth a mandate for regulation. But obviously, it's important to keep a track of where are we right now in terms of meeting our energy efficiency goals. Are we getting there towards the 30% efficiency by that was aimed to be achieved by 2030? So I'd like to start the discussion with Deepti from a third-party consultant perspective. How critical is LEED in terms of factoring the current regulatory trends across the UAE?
Azra, just to clarify that in the capacity of a certification body, we have been engaged with different project teams of various project typologies, different occupancies, various square footage, you name it, and we have the project currently working with us. And most often, people complain about the fact that LEED is extremely stringent in terms of setting our guidelines. We also take pride in the fact that we work collaboratively with the market so as not to leave anyone behind. And if you noticed my presentation earlier, we've not reinvented the wheel. We've actually based our net zero program so as to open more avenues to participating projects, to be able to give them a chance to improve as well as incoming projects. So we've always followed an incremental approach, and specifically in the context of UAE or any other geography for that matter, climate emergency is out there, it's been declared. So we can only anticipate that governments will put down protocol at a much faster pace. But are we equipped to deliver at a pace that is expected out of these governments? And that's where, our incremental approach has really worked in our favor to be able to. So today, after watching our presentation and discussion, if anyone wants to say, I want to go LEED Zero, there you go. Do you have a LEED certified building? Are you out there? Are you in a participating operations and maintenance project? Go get registered tomorrow itself, right? So that's the pace we want to keep up with. I hope I addressed. Yes.
Absolutely. And I think the LEED rating, the LEED system, the rating system in itself provides a framework for hotel, for building operators in general to do their self-evaluation and take accountability of their energy consumption and emissions. And beyond the emissions, it's also looking at attracting tenants. If we are building operators, it's moving from pricing out tenants to attracting tenants. So that kind of ties in with the whole objective and perspective of sustainability and building a sustainable business portfolio. So moving forward, my next question is directed to Mr. Hassan Yunus with respect to the design aspect and also the building services aspect of the built environment. Building services account to 70% of the total energy consumption typically in a building property, and some of the big ticket items is HVAC, electricity from the lighting systems, from the pumps. So in terms of my question would be in terms of retrofits. How conducive is the market now? I mean, because 30,000 of our, I mean, a large number of our building stock are comprising of high-rise commercial buildings. So how do we see that? How do we see net zero being implemented on these type of typologies?
Thanks for the question. We should move away from net zero buildings to net zero cities. It's not going to work on high-rise buildings. There's no way a building on Sheikh Zayed Road with 50 floors to become net zero by adding some PVs on the roof. I mean, you still need the windows. You can't even close those. So we need to look at a net zero city. So your building will focus on these buildings where you have high-rise buildings on efficiency. So we can work on their efficiencies, drop their EUIs to the best EUI we can get, and then work on the buildings where they have enough roof to add PVs. And this is what happened in the US when the Department of Energy in the US, they've done a research on, okay, can we start talking about net zero energy building? And normally it starts in the US or Europe and then moves to our area here. Yeah. And what happened there is they looked at different buildings. They used main energy models and actual data from sites, and they looked at which buildings can get net zero. So if it's a 1-floor building, definitely he can get net zero. 2 floors, they based on the model that they've done, they got maybe 80% of those can get to net zero. The higher floors you get to, the lower the chances you have to get. I mean, if somebody's telling me, yeah, I have a net zero villa, well, great. I mean, it's not a good, I mean, it's not a super achievement because you have the roof, pay the money, you get the PVs, you get the net zero. But if like a building like Diwa Al Shira building, 15-story building, they have to go through hell to be able to reduce the EUI to the maximum, use this huge roof to put PV, and still I would argue that it's really hard for that building to get to net zero. So this is kind of pushing the envelope. So we need to look at the whole city. We can't look at one building and say, well, it's high rise, let's make it PV. We're going to put a lot of money, it's not going to work. Whereas there's a building next to it where they have enough roof where they can add that PV, and altogether the city becomes a net zero energy city.
Right. So yes, I think that's actually a very valid point. I think it's about having an integrated approach, as mentioned in previous slides by Marwan as well, from Schneider Electric. I think we need an intervention, a major technology intervention, probably looking into digitization and IoT to bring cities together. And ideally, we might see a future where the buildings might start powering each other through digitization and IoT. Is that like can that happen in the near future? Can we see buildings powering each other like a symbiosis effect?
Yeah, I would argue that we do this at the moment. So with Diwa's Shams solar program, you are connected to the grid. The thing is, synchronization of the grid is a little bit difficult, and you can see now that Diwa has reduced the allowed amount of solar that can be implemented on a single plot, because it doesn't need to be chaotic. We don't want to go to California. Or the issue that happened in California, where most of the PVs were being generated, and it changed the way the demand looks like, and it went into what we call the duck curve in California, and too much PVs at points in time might not be good. So we need to look at how can we store that energy and look at the grid level, and that's what I think DIWA is doing, trying to mitigate these issues by making sure, okay, we are providing PVs. And what happens during the night? If you only provide PVs without storage, that's not going to help. So we need to look at thermal storage, so district cooling with thermal storage, looking at electrical storage and other means to be able to shift the demand from here to there to make sure that we get a real net zero city. I mean, now we are still in the beginning. It's easy. We can put in more PV. We still have a long way to go to get to California or other places like Germany. But in the future, we need to be careful about these things, and definitely communication between different buildings, different systems, to make sure this integration happens without any problems to the grid. It's very important. Right.
So essentially, yes, it obviously means a combination. We need a combination of technologies, and it's going to be an iterative approach. So it would vary from various typologies, and obviously there's a thumb rule of first reducing and then beginning with the high end, implementing or investing on renewables or solar PVs on existing buildings.
Yeah.
Right. So so just to wrap up with Mr. Johan Kama, who's going to give us some perspectives from the contractual side of things. How is it like at a ground level, complying to green building standards and in terms of what are the common challenges? Sometimes at times contractors have demanding timelines and various design changes and challenges. So is it always easy complying to the design criteria at the contractual stage of designing a building or implementing a building?
Thanks, Deepthi. I wouldn't, first of all, I would never say it's easy to implement to the design stage criteria when you come in with, say, so Multiplex, how we work is we really enjoy working on a design and build project. That's when we get to showcase most of our understanding on a building. When it comes to a design and build, the contractor comes in at such a late stage that it's difficult to influence the design. And that's where you get really limited in terms of pushing the building to its fullest, say, potential in terms of the envelope or HVAC designs. So when you put into perspective compared to a design and a build only, we have done a few projects on a build only, which we have pushed from a LEED Gold to a LEED Platinum. That's because of your construction stage or say a bit of design change during construction, but it is very limited. However, the project that we're working on, which is the school in Tilal Al Gaf, it's a design and build, and we started a stakeholder engagement and a collaborative approach with the client along with our supply chain, and that's I think a very important factor here, to work with your consultants, work with your stakeholders, make sure that they understand the concept and the whole life cycle of the operations when it comes to a nearly or a net zero. It's a lot more easier to influence nearly and or net zero approach when you are working with the client who's also the operator for the building. Usually when you're working with a client who's going to sell off the building to some third party, it gets really difficult to bash heads with them. So yes, it is difficult depending on the type of the contract that you're working on. However, I don't feel you need to learn any rocket science in order to gain basic understanding of complying with the local regulations. However, I'm quite aware that they're not stringently followed, especially in Dubai more than Abu Dhabi, I would say. So authorities would have to definitely push in to get the desired results and the targets for Vision 2030 or 2050.
So it essentially is, it's a matter of accountability and transparency, and that essentially has, at times, yes, it should be a part of a mandate, but obviously we all have to join hands together to make sure that correct information is incentivized, or entities that do perform as per prescribed or recognized standards are meeting those minimum criteria. Say, for example, uploading documents or certifying a project for LEED. The documentation is authentic, is accurate, and is being validated throughout the design and construction process. So at such stages, it would be essential that we would have checkpoints at each stage of submission. So prior to the submissions to the third party consultants such as LEED, we have like internal checks on the documentation. So from that perspective, I'd like to get some insights from Deepthi as well. How, in terms of complying and stringency in terms of complying to standards, how is that taken into consideration today here in the UAE to avoid any greenwashing?
So, our previous discussion started with people complaining that LEED review teams are extremely hands-on when it comes to reviewing projects and reviewing requirements. We give projects an opportunity to pre-certify for cities and communities for that program alone. Right. So because it's a project of a very large project boundary area, as well as because of the fact that too many stakeholders are involved, we do not want the project teams to put everything at risk and submit everything together at a later stage, wherein initial project changes could have been made. Taking King Salman Energy Park in Saudi Arabia as an example, the project team initially did not meet a prerequisite of green open spaces. And this is a story that we tell almost all of our stakeholders in the region, because them being an industrial city readily agreed to increase their open spaces by 30% to factor in all the associated activities that would happen once the city was up and running, such as social wellness, happiness, etc., etc. So all these factors come into play at the pre-certification stage. And then, of course, you have your design review submission as well as construction review, which is a split review, or you can go for a combined review. Yep. Now, having worked on the other side of the table as a consultant for many years before joining GBCI, I can only say that project teams are entirely accountable for the accuracy of data that they declare. And of course, GBCI review teams, from our perspective, perform those checks at every given interval. And these days, information is so readily available and out there, it's not too difficult to find out what's going on in the UAE, in spite of review teams being located remotely. So nothing's taken for granted, luckily in the UAE, and people do stick to the rules. That being said, word of caution: any consultant can challenge a project certification for up to 2 years after the certification has been awarded. So that is something that we've put out there for just to keep the market going in the most accurate manner as possible. Yeah.
Right. So obviously, I think that there is that would help project developers and even client representatives represent their brand in a more transparent and accountable manner as well. How do we see the trend coming into, say, for example, at an industrial level? How do we see LEED being implemented on FMCG outlets or manufacturing outlets? And does it compare to other rating systems like the GHG protocol?
That's a very good question, because specifically taking Dubai as an example, we've had some discussion on the chat box about how local rating systems have come into the picture and where does LEED stand today. So thanks to Thrakki's rating system was very closely aligned to that of LEED about 10, 12 years ago. So we have nearly 100 projects in Dubai certified in the Jebel Ali free zone area, thanks to the fact that project teams decided to take one step further and also go for LEED certification alongside the Thrakki's approval process. With that, we've seen a lot of industrial manufacturing, warehouses, all of these segments getting added to the portfolio. We've also seen a lot of diverse users coming in terms of new construction, as well as existing buildings from other parts of Middle East, such as Saudi Arabia, given the fact that all giga projects in Saudi Arabia has a sustainability mandate. And as Nazli mentioned earlier, MAF is one of our largest portfolio holders of LEED in the region, in the Middle East region. And because of these internal mandates, project teams are also encouraged to, they know what to follow, right? So even if there's been a handover in the last 10, 15, 20 years of project teams changing, everyone knows that this is the baseline that we've got to follow. Whatever we do from then on is an addition, is a bonus. So yes, we do have different sectors coming in. After COVID, I must admit that we have seen a lot of interest from warehouses and data centers, especially in the region. Their willingness to participate has been very high.
Oh, that's it. And what could be the reasoning? Is it mainly because they wish to be more responsible, or is it because of the mandate coming in?
So it's a different discussion altogether, because I was at this Women's Day talk show a couple of days ago, and I asked the audience, how many of you have looked up at your ceiling and wondered what's going on behind that? So quite a few of them told us that ever since the pandemic, we've just been locked up at home. We know that indoor air quality and health and wellness matters, because of which we've begun to take sustainability and green buildings very seriously. So looking at the bright side of the pandemic, I would say that the interest has been generated by the fact that health and safety within buildings is extremely important. That point has started shining ever so bright, because of which even data centers, energy guzzlers, right? So all of them have started looking at green building certifications from a different angle and in a positive angle. So that's
absolutely. Yes, especially with the COVID-19, many stakeholders within the built environment see the importance of adopting health and safety standards and bracing to this new normal. So yes, I think we do see a lot of intervention and technology breakthrough with respect to indoor air quality. And it's nice to see some new trends in terms of benchmarking as well. The ArcScoru platform really covers those aspects. It not just looks into energy and utilities, but it also looks at indoor air quality, which is great for hospitality as well, in maintaining their indoor air quality levels from PM10 to CO2 management. So all of these aspects are very important. So thank you very much to all the panelists. We might have a few questions come in from our audience. Okay, so far, everyone, any questions from the audience? So far, there haven't been any questions. Before we wrap up, any final comments from our speakers, our panelists on the panel today? Oh, we have one question coming in, sorry. Let me see if I can just quickly scroll. So there's a question from one of our attendees. Using mechanical blinds, I think this might go out to our design consultant, MEP expert, using mechanical blinds with PV in all the windows, on all the windows, is that something that could work on buildings? This is a question for Hassan.
I personally don't like blinds, so my house doesn't work in my house. But I mean, look, I mean, everything could work in a particular case, but I mean, that's not the solution, definitely. But every little bit of extra production or energy efficiency definitely will help, whether it's PVs on the blind or PVs on the windows, or it does work in some complexes.
Right. And is it more effective? I mean, I know we just came across one academic research by Inas, and she mentions using passive measures prior to implementing active measures.
Yes.
So especially with respect to retrofits, is that the most effective way? And what is the importance of commissioning in existing buildings?
Actually, I just did I had a course today with Gbci on energy audits and commissioning. So basically, definitely passive measures are first things you need to do. They're easier during the design. I can't change the shape of a building or the window ratio. In an existing building, I can add maybe insulation, change the windows to a more efficient and lower solar heat gain coefficient and higher U value or lower U value. But I cannot change the shape, cannot change the window to ratio. So yeah, and these tend to be expensive in the context of how the retrofit business is going on in the region. So we're looking for 5 years payback or sometimes 3 years payback. It doesn't work. Like just changing the windows will have a much more higher payback. So there's something we didn't talk about here is the money. I mean, everything's driven by the money. Yep. So if it's not feasible, nobody's gonna do it. Even we're gonna tell everyone, okay, the planet will end. They won't care if it doesn't make sense financially. So it has to make sense financially before we apply any measure. And from the retrofit point of view, commissioning-wise, commissioning for existing building is more of looking at non-functional systems. So I wouldn't do commissioning just to save energy. That would be part of it. So I always compare the energy retrofit versus the commissioning. The commissioning is like a major in commissioning and a minor in energy retrofit. What is the energy retrofit? It's major in energy retrofit. So we're trying to reduce the energy. At the same time, yeah, we might look at some of the systems that might not be very high intensive in terms of energy, but we might commission them on the way. And it would involve mostly change of systems. So when we say energy retrofit, it should be change of the chillers or addition of some equipment. With commissioning, we're trying to bring back the systems to work as they were intended. And first thing we need to do is the current facility requirements. It's like the OPR or the ownership project requirements for a new building, but for an existing building is basically telling the owner, what do you want from the building at this point in time? How do you want it to function? So normally commissioning would start from problems in the building, energy being maybe one of them, but it's not the main item on the table. So that's the difference between, but definitely commissioning can bring up to 30% of savings in some cases if the building is really terrible in terms of managing their energy consumption.
Right. So ideally it's more of a preventive maintenance. Can we say that it's more of a preventive maintenance measure?
It's like your car. When you take your car and service it, okay, it's more of like maintenance plus commissioning. So you know that there are some things you need to change, but you also look at some things that you feel, oh, this might deteriorate your fuel consumption. So they will tell you we need to change this part. So it's kind of like that with commissioning. We're doing some investment, but it's not very high in terms of capital cost. When we go beyond a certain level, that kind of becomes more of a retrofit.
Right. So ideally, what should be a rationale followed for typically if if a developer, real estate hotel operator or building operator would like to look into retrofitting their building property, what should they start off with first?
Benchmarking, I would say. I mean, that's the first thing we need to do. We need to do benchmarking, see compared to others are doing well or not, and then move into a low-level energy audits, or is it level 1 or level 2, depending on what you find from the portfolio. If, let's say, you have 20 hotels, you find that 5 of your hotels are doing really bad, I would suggest go for a level 2 audit, get a consultant, get an RFP out. You don't have the money, or you have the money, want to guarantee the saving, get the consultant. So we work, let's say now, with clients like TCOM, like Abu Dhabi DOE, where we're managing the whole process for them. So we write an RFP, bring in the ESCOs, they bid, we select the ESCOs, of course with the client, we'll supervise the implementation, we'll supervise the IGA, investment grade audit, then the implementation. Then we do the measurement and verification. Either we do that as Griffin, or we vet the reports coming out of the ESCO so that the client is sure that they're getting the savings. And the ESCO also has a counterpart that they can talk to in terms of technicality. Sometimes the client does not have that. And we've been in a case of 100+ million dirhams between an ESCO and a client. They went to court basically because the savings were not there, or the client thought they're not there. The ESCO is saying, no, it's there. Well, they're kind of where and where not in reality. And then it ended up, in court. So if you don't have the proper channels and the proper umbrella to really guide you through this, some of these projects will fail. And at the end of the day, failure after failure will lead to a failure of the whole system. So this is like similar to green building. If green building did not show any benefit, it wouldn't have continued to thrive. If, let's say, we did first 2 green buildings and we found that, indoor air quality still is bad and energy efficiency is still bad, we wouldn't have continued that.
Right. So we have some questions coming in from our audience. One of the questions is again an extension to the retrofit model and the role of ESCOs. How successful have ESCOs been here in the GCC, and how different is it from a turnkey project? Yeah.
So again, so ESCO projects, some of them have really been doing very well. So let's say we have our DOE project in Abu Dhabi, which won the CIBSE Building Performance Award for the building retrofit. So in that project, there was around 35% of savings, and actual real savings vetted by us. So in that project, it obviously worked. And other projects where the method was not very, let's say, systematic and doesn't follow proper standards, like the case I was talking about, where they thought, okay, we're going to put these systems, they assumed wrong values for the baseline, they assumed wrong values for how much they will be saving. End of the day, client comes back after a few years, doesn't see the savings, doesn't see change in their EUI and their bills, they go into problems. But in general, I see it is a very viable solution for developers to guarantee their money. So if they have the money, the ESCOs can guarantee the savings by putting bonds against them. Or if they don't have the money, there are some ESCOs that can provide shared savings, so they put the investment. But without a third party, I'm not just trying to promote, let's say, third-party consultants for these projects, but without these, I've seen like 50% of the cases, there will be some issues in the measurement and verification phase where something will fail.
Yeah. So I mean, obviously, it has to be it has to be reviewed against, I think, taking various previous lessons learned from previous projects and really understanding the situation at the moment. I think it's important to verify and validate the energy consumption before and after. And as mentioned, it's very important that the data is accurate and is clearly mentioned. And at times for the client's benefit, it's generally it's always better to have a third party review or a consultant to validate the data that's been concluded from the energy efficiency measures. So with that, we have one more question coming in for Hassan. It's a more technical view on what kind of HVAC systems or what kind of what the FCU and the DOAS configuration considered incorporated into the school project that was presented earlier.
So yeah, the original design had fan coils for the rooms and for the spaces, and a dedicated outdoor air system with double heat recovery. Now with the net zero energy case, the load has changed. So obviously the amount of flow going through these units, especially on the fan coils, has reduced, as well as using electronically commutated motors, which are way more efficient than their alternating current counterparts, induction motors. So yes, there is a huge reduction. Also for the fans on the DOAS or the FAHU, whatever you want to call it, these are also using plug fans that use ECM or EC motors. So definitely there is a huge reduction on that as well. Let me add one more point. In any case when it comes to energy, the first thing that needs to be looked at is the tariff. So if you look at the tariff between Dubai and Abu Dhabi, if you look at the commercial, let's say, rates, in Abu Dhabi, paybacks will take much more time for the commercial sector because the tariffs are much lower. So we're paying 0.2 versus 0.4 or 0.44 in Dubai. So that's always the first thing you need to look at to say, well, it's feasible or not. I cannot go to a client and tell them, oh, we get you the payback in 50 years, but it's a very nice system. They're not gonna take that and apply it.
Right. So Obviously, yes, in terms of paybacks, yes, that would have a significant impact if the tariffs vary by at least 1 to 2% between each state. But do ambient conditions and ambient temperatures have an effect between each emirate? Have you seen that come through and through the building design modeling or energy modeling?
Well, in Al Ain, it's a little bit drier, but it doesn't have that huge effect. Whereas, let's say in Riyadh, you'd use better. Like, there's a question here: do we use radiant cooling, radiant heating? If I was in Riyadh, I definitely will be have more courage to use that system, because we have a dry climate. We don't have the issue of condensation on the radiant panels. So in here, it still can be done, but has to be a very tight building, and it definitely will improve on the energy consumption. We've designed a net zero energy city in Saudi, where we've used it's more of a like whole city approach, where we've used radiant cooling in like super high efficient buildings, where we're using the return of the district cooling to feed those buildings in terms of chilled water, and the other buildings that have the normal systems are using the supplied chilled water. So yes, definitely radiant cooling is one of the questions that were mentioned here. It works, but works better in drier climates where you don't have this issue of condensation because of high humidity from the outside.
Great. I believe we're very close to closing our session. Just a couple of minutes away. I'd like to thank all of our panelists, Deepti, Hassan, Johan, for participating on our panel discussion. Before we wrap up, it'll be great to get a few comments and quotes on, where do we see a future with net zero, and what do you think about net zero here in the UAE? So I'll start off with Deepti.
A great way to end the discussion. So I think my comment would be, if the intent is there and if the intent is right, then there's no limit to achieving net zero. So we have both. So it's just a matter of time before we get there.
Absolutely. So I'll move the floor to Hassan.
Yeah, I mean, let's hope for the best. I think net zero energy is a need that at one point in time, we will have to go there. It wouldn't be an option with global warming and all that. I see that we as individuals, as companies, as a whole society, as a whole world, we need to put the greed aside and start working on the problem, rather than always focusing on the return on investment. And we need to put some money in that. We know it's not going to be coming back in 20 years. Maybe it's going to take more in order to get to these really bold decisions and get to real net zero cities. I think obviously governments, since they are taking that lead in putting the solar, let's say, farms, which is very helpful. And they're doing, let's say, most of the work till now. If you look at the amount of energy coming from solar, it's mostly given by the government. In order for the private sector to also participate, I mean, we've seen presentations from MAP. I think we need to put the greed aside, work all together to get to net zero energy cities.
Yeah. I agree. I couldn't agree more. It's about having a continued dialogue and working collaboratively. I'd like final comments from Johan. Hi, Johan.
Hi.
Hi.
Yeah.
So from contractor's perspective.
I would just say if the consultants, the likes of Hassan and all, design net zero buildings, we'd be happy to build them for them, the clients. But on a serious note, yes, it is going to come a lot sooner than we anticipate. It is going to take a collaborative approach and not just a few companies doing it. So collaboration and early stakeholder engagement, supply chain also is very important, because beyond design, it's all on the embodied carbon and stuff, which is huge in terms of the contribution from contractors' point of view. So yeah.
Great. Thank you very much to all of our panelists and speakers, I mean, for providing some trailblazing research and insights. And we hope that we can continue our dialogue for the next few months, or within the next quarter, we could have a continued collaborative dialogue. But yes, to make net zero a success here in the UAE, we have to move beyond working in silos, but working more collaboratively in an integrated manner, taking principles of lead, addressing the various big ticket items that not just are faced by the built environment, but beyond the value chain as well. So we're moving beyond the built environment. We're looking into transportation. We're looking into embodied carbon in materials, and what and how are we responsible as individuals in meeting our net zero goals. So I'd like to give a round of applause and a big thanks to CIBSE UAE for organizing this this amazing first day virtual conference. And thank you to you guys. All of you are the trailblazers and the pioneers to net zero development here in the UAE. So round of applause to all of you guys. And I'd like to thank Farah and welcome Julian and Farah to make some final comments and notes for day one of the Net Zero Virtual Conference.
I'm just going to jump in. Sorry,
Go
Julian.
on, Farah.
Yeah. And to say thank you so much. First with our panelists and Azra for doing a brilliant job in initiating the conversation. And thank you to all the speakers for being with us today and sharing your research insights. And also the attendees for engaging with us and asking questions. The questions that hasn't been answered today, we will get back to you through our social media circles. So please join us and look up CIBSE UAE in LinkedIn and social media. And we would be very happy to continue this conversation. And thank you again for being with us on the day one of the conversation. We look forward to seeing you tomorrow. Julian, to you.
Hi everyone. I know that it's time's up, but once again, thanks Azra. Thanks Azra for that moderation. That was expertly done. I did have a present. I also did like that Deepti opened her blinds just as Hassan was railing against blinds, but that was like a little amusing that. I did have a presentation, but all I wanted to say was that please join CIBSE if you can. I won't share this presentation because time is up. If you would like any assistance, please email regions@cibse.org and we can guide you through the process. One further thing to note is that the UAE Awards are going to be taking place next month. So all the details on that are available at cibse.org/UAE Awards. And hopefully see you tomorrow. Thank you.
See you tomorrow. Bye-bye, everyone.
Bye.